Ladies and gentlemen, let me introduce you to Jensen D. Rockefeller. AI is the new oil. But does anyone actually know what it means?
Nobody knows what it means.
But it's provocative.
Drill, baby, drill.
Look, oil wasn't valuable because it existed. It actually was just valuable because Rockefeller controlled the refining and the distribution. He made crude oil into something that people can actually use.
So how does it relate to AI, Mark?
Well, AI isn't valuable because models exist. It's valuable because we can actually use the AI by running inferences, so asking requests to the AI. And of course, that also needs entire distribution and everything else.
How does it tie into NVIDIA, Mark? And why is NVIDIA out of a sudden so fucking valuable, like $4.5 trillion, like the most expensive company in the world?
To continue with this metaphor, training is basically the drilling. So think about it this way. Training a model, like models need to be trained. All these models that you guys are familiar with, ChatGPT, Meta's Llama or Claude, they have trained on data. And what do they use for training? They use chips.
NVIDIA, baby.
Oh, hell yeah. So this is the drilling. And basically, NVIDIA's chips are the best in the world for this because they're using CUDA technology.
Well, CUDA technology is basically internal. It's developed by NVIDIA, and it's the gold standard right now for AI training. And you have to think about nowadays these data centers are huge; they're gigantic. So NVIDIA,
enormous.
I mean, OpenAI wants to build gigantic ones, and for these data centers, some in the US might need actually what's it called?
Nuclear power plants.
Exactly, that's nuclear power plants, which is freaking crazy. That just shows the size of this. And now, Mark, so GPU, but we also have different ones, right? We have not only GPUs, but NPUs and LPUs.
Well, this is the where we're getting, right? We got the refining now, we got the drilling, now we have the crude oil. What are we going to do with the crude oils, Lucas, with the models, right? We have the models. So now we come into what you're talking about, right? Because with the crude oil, nobody can use. AI models, no one can use if you can't access them. So now inferences is the same as refining in the pipelines. And this is where you come in, where you just said exactly about the LPUs, NPUs. Lucas, just go in every detail. What is it? Also, what is a CPU for those who are not technical and have computers, but no idea?
So first of all, GPU is a graphics card. Then you have an NPU, which is the neural processing unit, and you have an LPU, which is a language processing unit. Just to make it simple, GPUs are the graphics card, or also these cards or chips that are in these huge server centers that actually train these models.
So what GPUs are basically in everyone's console PC, right?
Exactly. These are smaller versions of it, but in theory, yes. So that's actually how NVIDIA started. NVIDIA started as a graphics card, producer for Atari. That was their first client, and later on, of course, like everybody has in their gaming computer, in the console, you have it there.
But there's also AMD, but yeah.
Now, so GPUs are basically right now used for training as well as for inferences. So they're really good in both. They're like high, for training, they're perfect. But the problem is they also use a lot of voltage, because they're basically like a workhorse. It can do everything, but it's not super great at everything. So it's just like, it can do everything. It's a generalist. Then you have on the other side the LPUs, which is a very niche. So LPUs is language processing unit. They're just down there for literally inferences. So inferences are the requests. So if you have a question for ChatGPT, you send a request, and that inference sends you back an answer. Now, these LPUs are so specific. So think about GPUs as the Swiss Army knife, like good for a lot of things, not great at one thing, whereas the LPU is really great at one thing, and that's inferencing. That's why the entire structure of these chips is built for this, make it more efficient, as well as giving you more throughput. So throughput means how many tokens per second it actually can spit out. So basically, if you have 30% more throughput, that means you can make 30% more money as well, because you can.
Why, Lucas? Why can you make more money with this? I don't understand.
So the thing is how currently AI works. So that's also now let's refer to SaaS. So for example, right now, every time you have a request, you pay for this, right? So every startup right now is paying per request if they don't host the model themselves.
Okay.
Because
And SaaS you're referring to as software as a service.
exactly. So let's say back in the day, SaaS services, you just had a server and you had the software. So everybody, each new client didn't bring you additional costs as long as you stayed in that one server range. And then if you have like 1,000, 10,000 users, you might have to upgrade the server. But that's basically it. You don't have per each usage more costs.
So it's more of a back in the days, pay once and then it scales, but at some point you have to upgrade versus pay as you go.
Yeah.
Every new request is going to be new cost. So it's more of a almost like a constant that it goes one by one, the unit goes up, and you don't have the economics of scale, so to speak, in that sense that much.
Yes, exactly. You don't have it that much. You could, of course, host it themselves, and then you again limited at it. But these models can be very, very large. So it doesn't sometimes most of the time for smaller startups doesn't make sense to host them themselves. It's rather you use websites such as Replicate or other ones where you can directly host these.
So I think that also another thing that you didn't mention, but the processing time is directly correlated to the price of that the user pays for it.
100%.
So that means for those users, for example, if you are generating an image, it takes 6 seconds to process. So that is why it's so much cheaper than generating a video, which is end of the day hundreds of video like frames or images, and it takes like 6 minutes. So it's going to be much more expensive to do so.
And that's like, for example, 2.6 15-second clip was like 6 to 7 minutes. And yeah, I mean, that one is relatively cheap. So it's like 10 to 15 cents. That's 15 cents per second. So you pay quick math, $1.8
Public
per,
math,
exactly. Horrible at it. No, actually it's more, sorry. Bad at public math. But yeah, if it's 10 cents. So that's like one thing that you have to be, no, $2.25. I'm sorry. This is $2.25. If for 15 seconds, if 15 cents. But then on the
this
other
will be edited out later.
But then you have models such as Sora 2 Pro, where it costs 50 cents per second, and then it just adds up quickly. Let's say you have a 15-second clip, $7.50, that's a lot. So that's why new AI startups have to really make sure that they're offering enough value for the users. For example, us with Hook Talk. So Hook Talk, we are now niching down on the beauty niche because we're believing we can offer more value. And then also because we offer more value for them, can charge more. This gives us also more leeway for the margins. Because otherwise, if you look at these, especially when you do video generation, it's very pricey. So that's why you have to make sure that you're in a niche where you can charge more. Because, for example, one of the things that we're looking at or we're looking before was Higgsfield. So Higgsfield is basically a platform. It's now over $1 billion worth, a platform for general video generation. So you can create cool trailers with it. In the end, they're just a platform which hosts the latest models. And the interesting part there is they're offering, for example, unlimited Nana Banana for an entire year.
Yeah. Okay. They do that, but they do it differently. They do it as smart. Look, they say, look, guys, you can do it for free, unlimited if you just have this plan. But they do something different. They do say, like, look, you have a battery. Every single time you use it, it's going to be lower and lower until you hit 0. And then it needs 24 hours to actually recharge. So what it does is it sets an artificial limit of how much you can use it. So that's why it's like unlimited, wink, wink. But end of the day, it's not unlimited. You're going to hit a natural limit, but it's a smart way to do it, right? Because you have to come up with something that is a marketing wise that feels like someone can use it unlimited, but it's not, because people have to be motivated to pay for these plans, because it's pay as you use, as we said. Like, it doesn't matter. Also, when these startups say, yeah, we have our own models, yes and no. I mean, most likely they're using a base model and they might have fine-tuned it, but they don't train these things, because training a model is very, very expensive. Millions and millions of dollars. Hundreds of millions.
At the same time, do the users really care? Because in the end, the users think it's your model, but in the end, most of them use them. I mean, over the last 2 years, it was more like a wrapper, and now people are fine-tuning it more. But then you see it on with the fine-tuning that you can, if you have more proper own data, it makes sense to fine-tune it. But otherwise, you're fine with a wrapper because, to be honest, like look at, for example, Netflix. Netflix is nothing else than an AWS wrapper, if you think about it, but still created so much value that you can charge for it. Of course, they had all the all the video stuff, but that's the other stuff that you're adding value with. Also, Mark, for me, that's very interesting. How do we even end up with this topic? Is because we saw the announcement of NVIDIA, right? So NVIDIA was licensing Groq now for 20 billion.
Well, that's a big number. That's 20 billion with a B.
Also, Groq is basically they're producing LPUs. So that's why we never, I think we never mentioned it before, but basically they created the LPUs, which is so much better in inferencing.
So why is it better? Because think about it, GPUs are great at a lot of things, but there are, for example, there are specific. Look, because in video games, you have to think about it. GPUs are created for video games, and video games need to do a lot of complicated math when it comes to physics, so that the game actually runs. It needs to render a lot of things. It needs to multitask.
Now compare them with a normal CPU.
So basically, Lucas mentioned it earlier already as well, that you have a straight line. For example, a CPU can do only sequential tasks. So that means you go from 1 to 2, and then B to C. But what it does, for example, in a GPU, it breaks down a task into 6, 7, hundreds, whatever different things, and can run them at the same time. It's going to be slower each at the same time, but it can do it at the same time. Because think about it, imagine video games are complex in terms of it needs to render a tree, and the next to it needs to render a rabbit, or whatever it is. But you cannot have just render first the tree and then the rabbit, because that's not how it works, because it would have a really, really odd feel. And that's why, for example, I have no idea if you've seen this, but there are these developers that show how the rendering is done. So for example, the field of vision is the only thing that is rendered in some games, for example, or used to be. So if you have, this is the field of vision going straight ahead.
If you have VR glasses, right? So
exactly,
only where the eye's looking at, they're rendering it. The rest is just black because it just reduces the load on the GPU, so you can run it in smaller devices.
100%. Because imagine you have to render the whole map the entire time. This will basically make your computer not usable, or your graphics card couldn't do it.
It still happens on most of the games.
No, you don't render the whole map.
Not the entire map, at least the things that is on the entire screen.
Exactly.
On the screen, but not only on the view or the vision on the view, right? Because you not where your eyes, but the screen size.
Well, it's the same thing. Where your eyes go or the screen in a VR. Think about it.
In VR, but not in normal.
Yeah, that's the whole screen. Anyways, so it does multitasking. So what the LPU, coming back to Groq, what it does is it cut out a lot of things that the GPU can also do, and just focus on one narrow path of how the math or predictability goes. So for example, in anything AI, it's about predicting the next token, especially in these like like LLMs, right? The large language models. So it just focuses on doing this thing exactly really well. And that's why it's really good at having these models run and as an inference, so that we can do requests on it. But it's not good at all at training models. That's why GPUs are still the beast there. And this is also why NVIDIA thinks, you know what? People will train models, but at some point we have great models. Why not also have the inferences? Because he knows that the ecosystem, Jensen knows that the ecosystem will need to have cheaper ways to actually run inferences. So to request things from the for the LPUs.
Because you have to think about this way. You have basically on the bottom layer, you have these big models. So they need, of course, the training capabilities. That's why these big data centers are built. Well, once for training, but also for inferencing itself. And if you're only focusing on inferences, first of all, you have lower electricity costs. Electricity costs means also less heat, etc. That means you can build you can pack more chips in these data centers with the same electricity that it needs, and still make more money, because first of all, need less electricity, less costs, as well as more throughput. So this is more for the consumer facing point, which makes total sense, because you will have way more startups that are built on top of these models.
So it comes down to owning for NVIDIA. It comes down to owning not only the training side, but also owning in the sense of that they can distribute all this because they have a licensing agreement. Again, a licensing agreement makes here more sense because in tech, especially big tech, if you have already arguably a monopoly on AI chips, then owning something as well that is a big company already that might challenge you, well, some people might say there's a monopoly and the SEC would make this more troublesome. So it's much easier to just have a simple licensing agreement. And I say simple because at the end of the day, it's going to be crazy complex, but it's just much faster and you have less regulation to deal with a licensing agreement versus actually purchasing it.
One of the things that I believe is really important that Groq shows that specialization wins. With specialization, I mean, they are just focusing on inferencing. And the same goes with startups, especially in the AI now niche. It's so much more important to niche down and go into that niche because, first of all, you will be able to deliver a much better service, same as Groq does. And then you can also charge more because maybe in that case, you have more throughput, or in this case, you have more value that you can bring to your specific niche.
So these things relate then for the user, the end user. What this actually means is, and the businesses, founders, that it will be faster and cheaper to use these LPUs. So in the short run, what NVIDIA is doing is going to be a great outcome for you guys because LPUs are faster in latency. Latency is someone who games knows this stuff, right? You played, so you basically played a game and you ducked already behind the wall and you still got shot. You're like, how did I get still shot? Because at the end of the day, I was already behind the wall, but due to the lag or latency, lag is just a very large latency. Basically, it's how the gamers talk about it. They still got shot. And the same thing happens with AI. Like, what's the time it takes to respond to your first request?
Which is not really that important if you're texting with ChatGPT. But if you're doing more complex stuff, for example, we're using Lovable for development. And when we're seeing like lately, the last few days or the last week, there were so many issues that's like super slow for like a simple task. It took like 6 to 8 minutes. And that's where throughput helps a lot.
That's throughput, yes. That's not latency though.
Yeah, no, but exactly. It's throughput, but latency is important, for example, for calls. So, for example, if you have an agency, so on a phone line, customer support, etc. So
anything that's real time.
Because otherwise, imagine we're just talking over each other, right? So that's because the one is talking, and then the robot.
Who hasn't been on the phone with like the shitty ones? You tell something, hey, give me the number, please, for what you have to say, and you say 1, 2, 3, 4, and it's like the number. Please.
Yeah, but this is probably because it doesn't even understand. Well, like latency in this case would be more you talking on top of each other. So the one is like talking, and it's like when you back in the day. I'm not sure like how old our listeners are, but basically you're talking to the user, like in US or whatever, and then you just have the lag, and it just you talk, and then the other talks. You still had it back in the day, like a few years ago. Still
well, it's still you can notice it sometimes that there is a lag. It depends on your internet quality, right? So this is one of the things that will enable a lot of other things. And throughput is making agents, everyone is talking about agents, basically more complex AI tasks, easier and faster. Because, for example, right now, sometimes when we run something, a code, prompt, we have to wait 6-7 minutes. So this will make this much, much faster. And that is why Jensen Huang is a G. I mean, think about it. This guy has literally a tattoo of his company on his shoulder.
Wild.
That's fucking crazy. This is a amount of confidence and
dedication
to a brand. I fucking love it, and that's why he's Rockefeller.
Also, for me, it's crazy that his cousin, Mark? No, his second cousin.
No, it's a cousin once removed. Yeah, second cousin
that owns is the CEO of AMD. Just like if you think about Dosters family runs the chip business.
Man, awkward dinners at or Thanksgivings. Like, hey, what's up? How's AMD doing? AMD's doing not so well compared to NVIDIA.
But they're still doing well.
They're doing well, but think about it. 4 years ago, they were similar in GPUs, like capacity, than NVIDIA. But now, due to all the AI stuff, it is so much better. It's crazy. Like, I think NVIDIA outperformed them by, I don't want to lie, I think 6x. But
NVIDIA versus...
It is, while you look that up, I'm going to
So, Mark, let's wrap this up. Let's give a quick summary, especially for startup founders. What is the benefit, or what can they expect now that NVIDIA licensed Groq?
Look, end of the day, this is going to be a good outcome for you guys because you're going to have much faster throughput, meaning the AI will be able to do much more in a quicker time at a cheaper price. This will also obviously then relate to end users who are not founders, so not using it in a business related sense, because the response time will be faster in calls when you have something customer service you calling or you're asking ChatGPT. The responses will be much quicker and maybe even cheaper. Well, I don't think you'll get the as an end user, you get it cheaper because the companies will bolster their profit margins, but still.
Also, for the gamers out there, yes, right now, RAM costs are expensive as hell. Since Sam Altman, founder of, well, not founder, but CEO.
Getting flashbacks, Lucas.
Exactly. Oh, man. Basically, OpenAI, I think they ordered 30% of all RAM production in the world. And now the prices since September last year, 2025, went from 64 gigs of RAM from like $240, $250 to like $1,100 something. So more than 4x, which is crazy. Think about it. That just gives me flashbacks to back in the day, crypto, when graphics cards.
4 or 5 years, yeah, 100%. It's the same thing. All of a sudden, so for those people who don't remember, the 30, I think it was the 30 series, the 3070 was released, and usually the prices were for this like $400, the 70, and it went up to $800-900, up to $1,000.
But later the graphics card dropped again, right? So because more production comes, and the same will probably happen with the RAM. You now
but never went down so much lower. It's still much more expensive, like $200-300. Still $600 now. 600 is a 5070.
Yeah, 70, but the 60.
Yeah, 60.
Okay, Mark, I have now the stocks. So the last 5 years, NVIDIA grew by 1,350%. So 13x, roughly 13.5x.
And AMD?
AMD, what do you guess?
Wait, how many years? Sorry?
Last 5 years.
3x.
3.8x, so almost 4x, which is still fantastic, right? So market cap is 343 billion. Of AMD and NVIDIA is 4.5 trillion, so it's more than like 12x larger, more.
Yeah, 8x more they grew. And guys, thanks for listening.
Catch you next one. Peace.